Hi guys, hope you all are doing good. So in our previous videos we have discussed the what is quicksort and its algorithm, its time complexity. So in this video we're gonna see the code for quickslot. So in this video we will execute quickslot in C and understand every line of code in a very simple way. So let us get started without any delay. So first we're gonna see the code. First line is hashtag include stdio.h. So this line is used to include the standard input and output library. It allows us to use printf functions. So now look at this functions declaration. So we have declared quicksort, int array of size, and int low and int high, and int partition with parameters of same in void quicksort, and we have declared a function swap function. So these are called function prototypes. So they will tell the compiler that these functions will be defined later. So now we came to the main function. So we have declared an array. So program execution starts from here. So in the next line we have declared array as I mentioned. So the size of the array is 6. So this stores the size of the array. So now we came to here quicksort of array 0 n 1. This function calls the quicksort process. 0 is the first index, and now we have printed the slotted array. So on the next line we have created a for loop for int equal to 0, I is less than n, and I is incremented. So this loop runs to every element. Inside the loop we have written printf %d array of I. So we are going to print this each slotted element. So we have written 0 here finally. This means the program ended successfully. So now let us understand the swap function. So this function exchanges two numbers. Inside we have written int temp equal to star a. So store first value in temporary variable, temp equal to temporary. So on the next line we have written star a equal to star b. So put second value into the first position. On the next line we have written star b equal to temp. So it put saved value in the second position. Now the values are swapped. So now next we are moving to partition function. So we have given int pivot equal to array high. The last element is selected as pivot in this scenario. So the pivot can be any number. In this condition we have selected the last number as a pivot. So the array is, I have mentioned here, the array is 9, 4, 7, 2, 8, 1. So the array should be 1, 2, 4, 7, 8 and 9. It should be written like this. So we have the int I equal to low minus 1. So this variable keeps tracks of smaller elements. So this variable track the smaller elements. So now we are going to the for loop again. So int j equal to low, and j is less than high, and j is incremented. So this loop checks every element before the pivot. So inside we have written a condition statement. If array of size j is less than pivot, I is incremented, swap array of index I and array of index j. So if current element is smaller than the pivot, we move it to the left side. So that is the process in the quicksort. If the element is less than the pivot, we're going to, if the element is greater than pivot, we're going to move right side, and if the element is less than pivot, we're going to move the left side. So moving the small element position forward. So then we are going to swap the elements. So place the small elements in the correct position, correct location after the loop ends. So when the loop ends, we are going to swap array of index I plus 1 and array of high with index high. So finally we are returning I plus 1. So return the pivot index. So now we are going to understand the void sort. This is the parameters. So the function slots the array. So we are going to see the line. So the first line is if low is less than high. If there is more than one element, then slotting is needed. So next int pi means we are creating another variable here, pi. So this will stores this function partition array of low. So we are going to find the correct position of the pivot. So now quicksort divides the array into two parts. So left side. So this is the left side. So and this is the right side. So sort element before pivot, slotting element after pivot. So this process repeats again and again. The array gets divided into smaller parts. Finally, all elements become sorted, and in our example, this is our array as I given here. So this is how quicksort works. This is the code. Quicksort follows the divide and conquer technique. So let us run this. So we have successfully got the array. See, so here are 9, 4, 7, 2, 8, 1. So it is in ascending order. So the array is slotted. So let me type another example. Suppose I have given 10, and here I am giving 21, and I am removed here. So now the size become 5. So I am giving size 5. So 4, 7, 21, 8, 9. So it gonna prints 4, 7, 8, 10, 21. Let me run it. So we got the another slotted array. So this is the code for quicksort. I hope this lecture is clear to everyone. If you have any doubts, you can ask in the comment section. So thanks for watching, and see you guys in the next lecture.